Use C++ class inheritance and class hierarchies to provide structure and the efficient reuse of code within a project.
While that covers the fundamental, usage or purpose of a class, let's take a look at something else that has to do with the class structure and object-oriented languages, and that's the concept or the philosophy of inheritance. Just like inheritance works in biology, or in the real universe, inheritance works in code. In other words, a parent bequeaths or gives certain attributes to its children, and a child object inherits attributes or features from its parents. And in the example of C++ and Java and other object-oriented languages, it's code. So data and functions that are inside what we call a parent object would be inherited by a child object. Now in Java, a parent would be called a superclass and a child would be called a subclass. In C++, the parent's called the base class and the child object is called the derived class. Whatever you call it, inheritance works in a similar fashion or similar way. So if I were going to write a class to inherit from monster, let's say that we're going to have a more specific type of monster, then again it would be the keyword class. And for inheritance, let's say that I'm going to make a dragon, okay? And a dragon's going to inherit from monster. And there are different modifiers. There's public, there's private. We talked about those. There's also protected, which is an intermediate level between the two. But the easiest type of inheritance, we're just going to do public. And then what I would do is, this is the child class, keyword class, the colon, the modifier, and then I would type the parent class, in this case monster. It's publicly inheriting from monster. And if I do this, remember that an empty class specification has a semicolon. It's a good review of class structure too. Remember, every class has a constructor and a destructor, and we start out with the modifier public, and that constructor and destructor have the exact same name as the class. It's like a function, but sans the a return value or even void. If any other function I were going to write, if it didn't return a value and I didn't put void in front of it, that would be an error. But with a constructor and a destructor, it's not so. You can actually do that. That's what you want to do. So I would type out the class name for the function, and in this case, just empty parentheses, or if I needed to take arguments, I could take arguments. And then remember, we said sort of a standard practice when you're generating a project and debugging it before you publish the final version is you would provide some feedback. And this allows you to see inheritance in action. And if you get null pointer errors or you have inheritance issues in your hierarchy, you can track them down. And so I usually would say something like, building a dragon, destroying a dragon, whatever, to provide some feedback. Okay? And if that's the case, the destructor is the same, copy and paste, but remember there's a tilde in front of it, so that designates that as the destructor, and this is the constructor, same name as the class. And again, when a function goes out of scope, say that I built a dragon local to a function, then it would be destroyed, and the destructor would get called. Just like when I build the dragon, the constructor would get called. Okay? And so if I do this, right, if I build this dragon, then because monster is its parent, it gets all the things that monster has. Life, size, weight, monster name, all the functions, all the accessors, the display stats function, and rampage. And then the idea is any code that's specific to a dragon I would put here. So, maybe breathe fire. I don't know, something like that, or whatever you want to call it. So dragon breathing fire. Of course, in the final, product, we'd play a fire sound effect or dragon sound effect and show a video clip or some graphics or something, or rotate a 3D object or do something. But that's just an example. So I get all the functions in monster, but then any code, data, functions, methods specific to a dragon, I would put in the child object. But let's say, I could have other objects that could inherit from monster. I'm going to copy and paste. We'll make two mythological creatures here. There's a dragon. Now we're going to make a unicorn. So dragon and a unicorn. It also inherits from monster. And this time, I need to match up the constructor and destructor and the build statements. And we'll give it a member method. What's something that a unicorn does? I have no idea. Unicorn prancing. There you go. Prancing, okay? And we'll just call this prance. Whatever it is that unicorns do. Alright, so this is an example of two classes, they're child objects, derived classes, inheriting from a parent, the base class. Let me throw these comment tags in there just to show kind of where the classes end and begin and so forth. Okay. Alright, so these are blueprints for objects. And this way, the idea behind inheritance is that you want to shift your code as high up the hierarchy as you can. Why? Because it's less work. Let's say that I have 100 different objects that use monster or life form or entity or whatever as an ADT, what we call an abstract data type or a base class. I don't have to rewrite this code. I don't have to reinvent the wheel if I use inheritance wisely. So anything that they would all have in common, I want to put up here in the parent and the base class. And then when I build my different objects, it's much less code that I have to write. It's less work. It's less bloated, so to speak. Okay? And then I can just concentrate on the differences between a dragon and a unicorn, sans all the things that they have in common, which might be in their parent class, the parent object up here. So that's sort of the idea behind inheritance. You don't have to reinvent the wheel. You can reuse code, and it should be less work for you if you're careful to shift whatever you can higher up the inheritance hierarchy into your base classes. Now this also brings up the concept of an ADT, or an abstract data type. What's an ADT, an abstract data type? It's a vague idea, an abstract idea. So in other words, I never have a generic monster. I'm going to get a more specific kind of a monster. A dragon, or a unicorn, or a beholder beast, or a centaur, or a troll, or an ogre, a more specific type of object. Just like in real life. Let's use biology. Okay, we have life forms, but what kind of a life form? You don't really have a life form. You have a more specific kind of life form, a plant or an animal. And even then, it's more specific. You have a certain type of plant, a tree, a bush. And of trees, it might be a pine tree or an oak tree. Or if your life form was an animal, it might be a mammal, a reptile, a fish. If it were a mammal, would it be a dog or a cat? And if it were a dog, what kind of dog would it be? A Chihuahua or a Rottweiler? So that brings up the idea of hierarchies. In the real universe, in real life, everything is in a hierarchy, whether we like it or not. Okay, well, in the coded universe, so to speak, it's the same. In a large project, a large game, a large application, there is a hierarchy. The way to construct that virtual world, the way to construct that large project, is to develop what we call an inheritance hierarchy. This is sort of a simple example, but you get the idea. Now let's see how it would work. If I were to build or to instantiate, I'll erase all this code here. Well, let's see. Yeah, we'll just go ahead and erase all that, and we'll start over. Okay. So knowing what we know, let's build both a dragon and a unicorn on the heap. And how could we do this? We're going to build a dragon called Sue with a pointer. So Sue will be a pointer to a dragon. And that'll be a new dragon. Oops. It'll be a new dragon on the heap or the free store. Okay. And let's build a unicorn called Bob. Bob the unicorn and Sue the dragon. Same thing, pointer. On the heap or the free store, right? So let's compile this and take a look at the calls to the constructors for those objects. So you can see when we code this, we're building a monster, building a dragon. We're building a monster, we're building a unicorn. So when I build the child object, it then turns around and calls the constructor of the base class or the parent object as well. So you can see that by the way we coded the constructor code. But other than that, you'll notice that although the dragon and the unicorn have no data like life, size, weight, monster name, they have no accessors as such, they have no display stats, watch what we can do. Because of inheritance, even though they don't have that, we can call those functions as though they did. So we're not having to reinvent the wheel, but we're able to reuse all the code from the base class. So if I wanted to do that, let's use the accessors and we'll set some of the features on Sue. Okay. So we'll use our error because she's on the heap or the free store. And was it set monster name? And that expects a string, Sue. And Sue set life. Okay, and she's a dragon, so she's got a pretty good amount of life there. And Sue set size, and I don't know, let's say that she is 50 feet tall. And Sue set weight. Let's say that she is 4 tons. Okay. And finally, with all those pieces of data set, those attributes, let's display Sue. Now that we've set her up, we've created her and given her attributes, so to speak. So we'll call display stats. Okay. So each of these functions, it's not present in the dragon class, the child. It's present in the monster class, the parent. But it doesn't matter. We still have access to it because they were declared as public with the public modifier and monster. And even the data, although it's private and we shouldn't be able to get at it, we can get at it through the gateways, the public accessor functions here inside of the parent. So let's build that project, check our syntax. I have some issues there. I have the member named weight. Oh, because that would be set weight. There we go. Too busy talking to notice the code I'm typing. So let's run that. Okay. So what happens? We build our dragon, which then calls the parent object, the monster class. We build our child unicorn, which then calls the parent object, the monster class. Now we set the attributes. All of this is from the parent. It's not even present within the dragon class itself. But that's okay because of inheritance. We get that code. We can use that code. So it might not be so easy to understand the utility of it with only 2 small classes like this, 2 objects. But imagine a more complex project, a game, with millions of lines of code and thousands upon thousands of objects and a large and complex class hierarchy. In a situation like that, you wouldn't want to have to sit there and rewrite all this code needlessly for every single object. That wouldn't be the most efficient way to do things. So if you look at it from that perspective, you can begin to appreciate the usefulness and the benefit of inheritance and building an inheritance hierarchy for a large game or a large project. And of course, it would be the same thing for Bob, right? We could call all of the parent methods. And in addition, we could call one of Sue's methods. So I could say Sue, let's get Sue to breathe fire. Okay. Her method up here is breathe fire. Now, Sue can call breathe fire. Now, Bob couldn't call breathe fire, but he can call prance. Sue can call breathe fire, but she can't call prance. They can both call all their parent class or base class methods, but they each have their own methods that are specific only to their class of objects in our game or in our project. Okay, so if we did that, we'll do this, and then I'm going to copy and paste, and we'll just replace Sue with Bob. Okay, and that's acceptable, or that's doable up until we get to the point, all of these come from the parent object, display stats. It's okay until we get here. Once we get here, Bob cannot breathe fire because Bob is a unicorn. Only Sue can breathe fire because she's a dragon. However, Bob can prance. So let's change that. Bob prances. But other than that, they can all do the same from their parent object, their parent class. So inheritance and inheritance hierarchies become a very efficient way to code projects, to kind of reuse your code and not have to reinvent the wheel all the time. So we'll build that project and we'll run it. Okay. And again, here's Sue. Here's her stats from the parent class, and she's breathing fire. And now here's, oops, my bad. Should have changed Bob's name to Bob instead of Sue. Poor Bob. Called him Sue. He was a boy named Sue. No, he was a Bob named Sue. Ha 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 ha. If you like that song. Alright. I tried to be funny. Anyway, okay, so now here's Sue. Parent class, dragon breathing. And here's Bob. In this case, parent class and unicorn prancing.
More examples of class hierarchies.
This project is in Visual Studio, but it's just an example of a more developed class hierarchy. So first off, we'll take a look at globals. We have some globals here. And you can prototype a class just like you can prototype functions. So it's just a class prototype. And then we have some pointers set up to pet objects. And you can take a pointer to a base class object and use it to build or instantiate a child class object. And we're doing that down here in the inheritance hierarchy. So class prototypes, those are our globals. And then from here, we go into our ADTs, okay? And our primary ADT or abstract data type is the pet class. This is what a pet is and what a pet does. So it's data members, it's member methods, accessor methods, public functions, private data. Now, from pet, we have intermediate ADTs. All right, so from pet you have mammal, and then from mammal you have dog and cat. And then you have more specific dogs and more specific cats. So all of these are intermediate ADTs. In other words, they have a base class or a parent, and they also serve as a base class, or they're a parent for other children. Horse inherits from mammal. You have different kinds of horses: reptile from pet, amphibian from pet, and mythological from pet. So all these would be ADTs. They're not actual specific objects we build in the game, but they are representations of an object and ways in which we organize the code, or scaffolding. They're abstract ideas, okay? So those are the ADTs. Now, the actual objects we build in the game are here in the child classes header file. And so a Chihuahua, it's a type of dog, or a Rottweiler, or a Pit Bull, or a Poodle. A Siamese cat, a Persian cat, a Tabby cat, an American Shorthair cat. A Palomino horse, a Clydesdale, an Arabian, or a North American paint horse, okay? A parrot as a bird, or a canary, or a hawk, or an owl. A snake is a reptile, a lizard, a turtle, an alligator, a chameleon, a gecko. Amphibians, we could do a frog, we could do a salamander, a newt, or a toad, okay? So each of these, in addition to calling functions and accessing data members from its parent classes, all right, the ADTs all the way up the hierarchy to the top level ADT, the pet class, they also have their own member methods specific to that kind of animal, depending on what kind of animal it is. The mythologicals down here, again, the same thing, specific to that kind of animal. All right, so there's our hierarchy. Here's functions, and from functions we just have, several different menus that run inside of loops. It's just a console app. Haven't, utilized the MFC or the .NET framework yet to build a graphical interface or window. So if we were to run the program, we can look at how the inheritance is set up. And if I'm going to create a pet, I go sort of to the main menu and I can make a mammal. And from the mammal menu, I can select the cat menu. And then on the cat menu, let's say I want to build a Siamese cat. All right, so I build a Siamese cat. And then I can choose a gender. And I actually do have a Siamese cat, and his name is Sparky. Right, so I built a Siamese cat, and his name is Sparky. Okay.
Here's some other examples. This is just an example of another project. It's a kind of an RPG game example. And of course I gave it a cheesy name, Hills of Darkness. And it's just got a simple interface that's in a C dialog, a couple other dialogues used in the project, so that's it right there. And we'll take a look at the class hierarchy. Over here in Solution Explorer, I go through the classes. Once we get down past the globals, it sort of has a parallel hierarchy. In other words, there's multiple base classes at the same level. Instead of having sort of like an entity or a master object, great grandparent class, so to speak, like Java and a lot of applications and projects use. So monster is a base class for building like dragons and giants and monsters that derive from it as child objects, and character is a base class for building objects that derive from it. Okay, and then I go through, and then there's all the functions that are in character, and then player inherits from character. Dragon inherits from monster. Giant inherits from monster. And shaman inherits from character. And these are just different characters and objects inside the game that make use of this inheritance hierarchy. And I guess that's a little simple RPG. I do this, and let's do. Alright. And go around and find some inventory items. And I'll go over here. And let's see. What are these short rocks? To the north. These are just different objects that I've got. Then I'll go over here and I run into a dragon and I'll choose. Here's all my heal. Alright, well, so I survived. Anyway, that's just, that was a dragon object, which is a child of the monster class, and that was a player object, which is a child of the character class, to give you another example. And another example. Here's another example of a class hierarchy project. And it's just kind of a little Pokemon tournament style game. But take a look at the classes. You have kind of a pet class, which is sort of your abstract data type or master ADT. And then those are all the functions and things. And let me scroll down. And then you have animal, which inherits from pet, plant from pet, and mammal from animal, and amphibian. Then you have hybrid. You get really weird with the hybrids, public animal. In which case we decided to create some weird critters. So hybrid itself is sort of an intermediate ADT. It inherits from animal, which inherits from pet, and it itself is a parent of other child objects. So snake, and then we get down to the, here's some of the hybrids down here. This is an example of an intermediate ADT that gives birth to or is a parent to other child objects. So Snabbit, which is half snake and half rabbit, inherits from hybrid. Okay. And Liger, half lion, half tiger, inherits from hybrid. You can also do multiple inheritance in C++, unlike Java, so that you can inherit from more than one class. You can't do that in Java. You can only extend one class, but you can use multiple interfaces. So if you require multiple inheritance in Java, then what you do is you extend one class and then implement additional interfaces as required. But in C++, you actually can. You can use a comma and inherit from more than one class. So a Franther, he's part frog, part panther. A Junkie, he's part jellyfish and part monkey. So he's a junkie. And a Krog, half crocodile, half dog. He's a Krog. A Squeal, he's half squirrel and half eel. And all these are inheriting from hybrid. This is just an example of the finished interface here. Alright. And then there's class hierarchies there. There's other hierarchies posted up here. You want to go through here. I think that was like another RPG type adventure style game. Just a simple interface built with the MFC. It's a single dialogue. And it launches other dialogues and things. But again, just kind of illustrating the use of a class hierarchy. Here's some class inheritance hierarchy charts. Here's just an example of some other class hierarchies. There's just a level map, and here's a class hierarchy I did for a Java game called Mutant Wars. And it just shows the inheritance and how the inheritance flows from the ADTs, the parent classes, or what Java calls the superclasses, to the subclasses. Alright, and let's see, do we have anything else here? Here's a class hierarchy for a game I just did called Pirate Arena. Right, and it's multiple hierarchies. This is the character hierarchy with the ADTs and the superclass and subclasses. Here's a hierarchy for a little arcade game style polygon, uh, implementation. Here, I'll show you the interface, I guess. Pictures with 1,000 words. So this is the interface for the game. And the class hierarchy, the polygon class hierarchy, is for this little J-frame here. And then the character class hierarchy is what's taking place here, where the player builds a character. They can choose from 4 different character classes, and then they can play the game based on that class and that class hierarchy. Also, the enemies are constructed from that class hierarchy as well. And those are just interface shots. Okay. And let's see. Here's one called Conspiracy. Here's just another class hierarchy. And sort of the idea behind this game was take all the conspiracy theories on the internet and combine them into a class hierarchy. That was kind of fun. But anyway, that's sort of the idea behind the game. And this is sort of just just a simple interface there. You can choose an avatar and stuff for the player, and just different situations in the game.